Hello students, welcome to another video of AskPrep. My name is Aisha and today we will be doing the exercise 1.3 of chapter 1 of grade 11 mathematics. I hope you watched the other videos wherein we have solved exercise 1.1 and 1.2. Now, in those videos we have discussed what are sets and how do we represent sets and what are the different types of sets that we have. Okay. In this video, we will be talking about subsets, what subsets are, what are supersets, what are universal sets, single sets, and also about the intervals. And then we'll continue with your exercise 1.3. So let us get started. We'll first learn about something called as subset. Now, what exactly is a subset and superset? Let us have a look. Now, let us understand this through an example. Now, suppose there are two sets A and B. Set A contains elements 1 and 2, and set B contains elements 1, 2, 3, and 4. Now, in this case, if you notice, all the elements of A that are 1 and 2 are present in set B. Apart from these two elements, there are more elements in the set, right? So basically, the elements of A are present in elements of B. So here A is called as the subset. I will write it as A is a subset of B. And I will call B as my superset because it contains more elements than the elements of set A. I hope this is clear. Now, let us take an example. Now, I'm taking my letters A and E in set A. In set B, I'm taking all my vowels of my English alphabet. A, E, I, O, U. Now, how can I represent it as? Now if you notice, A and E are present in B as well. So the elements of set A are present in set B. So I will call it as A is a subset of B and B would be called as my superset. Now this symbol, I would be using this symbol. That means, as you have been noticing that I have been reading it as subset. Okay, I will read it as, it stands for subset of, a subset of, or you can also use is contained in. I'm used to using the term subset of, so it's okay. You can use whatever. I can say it as A is contained in B, or you can say it as A is a subset of B, whatever you're convenient with. Okay. Now, moving ahead. Now, let us have a look at another example. Now we have seen, let me take an example, 2, 3, 5. Okay. Set B contains elements 1, 2, 3, 4, 5, and 6. Now, you must have noticed that the elements of set A, that is 2, 3, and 5, are present in set B. So I can call it as A is a subset of B, correct? Now we are going to learn about new symbols. Please pay attention. Now, what have we seen? A is a subset of B if the elements of A belong, suppose this is my element, whatever it is, 2 belongs to A, and which implies 2 will also belong to B. Yes or no? If it is belonging to my particular set, which is a subset of another set, that means it should also be contained in my other set. Similarly, it holds good with 3 and 5. If 2, 3, and 5 belongs to A, that means 2, 3, and 5 also belongs to B. Now I have used this symbol here, which means implies. Now how will I read it as? A is a subset of B if 2 belongs to A, which implies 2 belongs to B as well. Yes or no? Yes. Now, let us have a look at another symbol that we are going to learn. Okay. Now, before moving on to that, I'm taking an example of A as my first three even numbers, 2, 4, and 6. Now, my set B is also containing elements 2, 4, and 6. Now, I have a question. Is A a subset of B or B a subset of A? Let us have a look. Now, can I write A is a subset of B because whatever elements are there in A, they are also present in B? Now, I can also write B is a subset of A. Why is that? Because the same elements, whatever we have been talking about, 2, 4, and 6, are also present in A. So here, A is a subset of B. Also, B is a subset of B. A. If and only if A is equals to B. Now, what is happening here? When is one set a subset of other and vice versa? Remember, we have learned something called as equal sets in our last video. What are our equal sets? If all the elements in set A are contained in set B and all the elements of set B are contained in set A, then they are called as equal sets? Yes. So, this happens when two subsets are subsets of each other only in the case when they are equal sets. Now, let me read this sentence for you. Okay. A is a subset of B and B is a subset of A. If and only if. So, this symbol stands for if and only if. In short, I can also read it as if. You see, I have written two F's, not one single F. Okay. So I hope this is clear. This symbol means implies and this means if and only if. I hope this is clear. Now moving on to the next concept. Now I am writing elements of A as 5 and 10. Okay. Now can I call A is a subset of A? Yes, because it contains the same elements, 5 and 10. So that means every set is a subset of itself. Clear? A also contains 5 and 10. Again, I'm talking about the same A here. So that means I'm talking about the same sets again and again. So every set is a subset of itself. Now, can you recall what this symbol means or how do I read this? Yes, this is 5. And what do you mean by 5? It means we are talking about a null set or an empty set. Now, every set contains a null set. Now, apart from 5 and 10 here in A, there is something called as nothing here. Yes or no? So, every set contains my null set. So, I can call it as null set is a subset of every set, not only A. Here, because I have written A, I have written it as phi is a subset of A. But in general, phi is a subset of every set. So, what have we learned? We have learned if two sets are equal, then the two sets are subsets of each other. Yes. And we have learned that every set is a subset of itself. And we have also learned that a null set is a subset of every set. Now, let us take few mathematical examples and see how we represent it in subset notation. Now, we know what our natural numbers are, right? 1, 2, 3, 4, and so on are called as our natural numbers. Now, what are my integers? Let us recall our integers. What are my integers? My negative numbers, my 0, and my positive numbers are called as my integers. So, can I write my natural numbers are subset of integers? Yes, absolutely, because all these elements or numbers are present in my another set of integers. Yes or no? Now we have learned the concept of rational numbers. Yes, what is a rational number? Any number that can be represented in P by Q form where Q is not equals to 0 is are called as rational numbers. Yes, now we have also seen that these natural numbers and integers are my rational numbers. So can I write it as all my integers are rational numbers? Yes, I can. Now, if you remember, we had a box I think it was in grade 9 or grade 10 textbook on the first page. It was something like that, like this. These are my natural numbers. These are my whole numbers. These are my integers. Again, these are my rational numbers. Whereas this is my R, and we have irrational numbers written over here, right? So what does this mean? This means all my natural numbers are whole numbers, all my whole numbers are integers, all my integers are rational numbers, all my rational numbers are real numbers. So irrational numbers are also again my real numbers. So these are subsets of one another. See, there is an order. I can write as natural numbers, subset of whole numbers, subset of integers, subset of rational numbers, subset of real numbers. Again here, irrational numbers, let me represent it by letter T. So irrational number will be subset of real numbers. Okay. Now we have learned about subset. Now, what if, now I have a question. Is T a subset of rational numbers here? No. T is separate, and here rational numbers, that are my irrational numbers, are a different thing, and my rational numbers are a different. So can I write T is not a subset of rational numbers? This is how I represent not a subset. Remember, belongs to, does not belongs to, the same way. This is a subset, this is not a subset. I hope it is clear. Now, let us move on to the next example. Yes. Now, suppose I am writing A is equals to 2. Now, this will be called as singleton set. What do you mean by a singleton set? That means it contains one and only one element. How many elements do you see in A? Just one element. Now, if I write, is this a singleton set? No, it does not contain any element. It is a null set, so it cannot be a singleton set. Now let me take another set. Let me write it as 3 and 5. Is this a singleton set? No, it is not. Why? It contains two elements. When we're talking about singleton set, it should contain only one and only one element. Okay. Now, I hope the concept of singleton set is clear. Now, moving on to the next concept. Your next concept would be universal set.